Okay, so let's establish this trig identity. Typically, we start with the more complex side, or the side that allows us more to work with, which is definitely the left side. So I'm going to rewrite that. 2 tangent of theta divided by 1 plus tangent squared theta, and then decide what that's equal to using what I already know, some trig, identities, or some algebra. Notice I'm not going to write that it's equal to sine 2 theta, right? Like you would for an algebra problem where you're working on both sides of the equation, because I need to establish this equal sign, to establish that they are indeed equal. So I'm going to start with one side, do some trig, do some algebra, and try to end up with the other side. These are challenging problems, but the good news is you know what the answer is. You know where I'm going to go. So when I'm done, it should be sine 2 theta. Okay, so there's typically a couple ways to do these. This one I can see a way to get there pretty quickly. Whenever you see something that's on your formula sheet, and you might not recognize this one as well as some of the others, but that's one of your Pythagorean identities. That's equal to secant squared theta. All right, so that's the first move. I know a lot of times we like to rewrite tangent as sine over cosine, and that'll work as well. But let's see what happens when I apply the Pythagorean identity for secant squared. Okay, so that's not bad. Now maybe we do, so maybe I'm stuck at this point. So now I'm going to go with my change everything to sine and cosine, which is a pretty common method. And of course, secant is 1 over cosine, so secant squared is 1 over cosine squared. And then I have a complex fraction here, so I'll have 2. We can put the 2 up top. That's the same thing. Doesn't matter. Dividing by a fraction is the same thing as multiplying by the reciprocal. Okay, if you wanted to show that step, and then there's one of these here, cancels out with one of those, and then you get 2 sine theta times cosine theta, and then you should recognize that as your double angle sine 2 theta, and we're done. Okay, if you didn't, let me show you that a lot of you want to do this by writing everything as sine and cosine right away. So let's look at that method. Let's see if that works as well. It should work. So that's 2. So right away we go sine and cosine. And then the bottom, instead of applying your Pythagorean identity, you go sine squared over cosine squared. Okay, and now I have this complex fraction. So typically what I would do with this is you could either add these guys together and then do the step where I dividing by a fraction, multiplying by the reciprocal, or you multiply everything by the least common denominator, the smaller fractions. It's kind of a matter of preference. So let's see what happens when I do it this way. So I multiply the top by cosine squared, so that would give me 2 sine theta, and then one of these would cancel out, cosine theta. And then on the bottom, I would distribute cosine squared. So cosine squared theta plus sine squared theta. And then that's equal to 1. Okay, so then from this step, you would just go to there, right? Because cosine squared plus sine squared, that's Pythagorean identity. So then you just have 2 sine theta cosine theta, which is sine 2 theta. So actually, they're about the same amount of work. So either way, I think works pretty well. All right, let's look at another one. I have established this identity, so I'm definitely going to start with the right side. It allows me more options. So again, I think I got sine and cosine here, so most likely I'm going to change these guys to sine and cosine as well. But first, let's do some algebra. I don't think it matters the order. We got to FOIL these, right? So it's a binomial times a binomial, so it's sine times secant, sine theta times secant theta. That's the F in FOIL, and then the O in FOIL would be secant theta times cosine theta. And then the I would be negative cosecant times sine theta, negative cosecant theta times sine theta. And then minus cosecant theta times cosine theta. Okay, so remember the goal, we know where we're going. We need it to be equal to tan theta minus cotan theta. So these ones, if you want, we can rewrite them. Well, let's just do it. We're going to rewrite everything sine and cosine. I think that's the logical step. So this would be sine theta times 1 over cosine theta. And this is equal to 1, right? So if you don't see it, you could just do one more step, 1 over cosine theta times cosine theta, right? Minus, and that's going to be clearly 1. And the same thing happens here. So I'll skip this step. That's 1 over sine, and that's sine. So that's going to be 1 over sine times sine is equal to 1. So I'm just going to do that one now. And then cosecant is 1 over sine times cosine theta. Okay, so this is 1 minus 1, so that's 0. So those are gone. And then I have sine theta times 1 over cosine theta minus cosine theta over sine theta. And that's tangent theta minus cotangent theta.